Hi, in this video, I will be showing you problem number 11 of chapter 9 section 5. Solve the differential equation x y prime minus 2y equal to x square with x more than 0. So far you have seen two types of differential equation. One is separable equation, the other one is linear differential equation. Linear differential equation will be of this kind: dy by dx plus p of xy equal to q of x. And the integrating factor for this equation would be I of x, which is e to the integral px dx. The integrating factor is the one that makes the left hand side of the differential equation a perfect differential. So we'll figure this out. As x is more than 0, we can divide the whole thing by x, the equation 1 by x. So it will become x y prime minus 2y equal to x square, the whole thing divided by x. So we get y prime minus 2 over x y equal to x. This way we have brought the equation into the form dy by dx plus p of x y equal to q of x type. So if we identify p of x and q of x, p of x is negative 2 over x and q of x would be x here. So if we find out the integrating factor, it is integral e to the integral px dx, which is e to the integral p of x is 2 over x dx. So it will be e to the exponent negative 2 integral of 1 over x, so that will be ln of x. Or it is e to the ln x to the negative 2, or it's x to the negative 2 is the integrating factor. The integrating factor can be written as 1 over x square. The purpose of finding this integrating factor is to make the equation 2, the left hand side of equation 2, a perfect differential. So we'll take equation 2 and multiply by the integrating factor. So we get 1 over x square of the left hand side of equation 2 is 1 over x square of the right hand side of equation 2. The left hand side of equation 2 is y prime minus 2 over x y. The right hand side of equation 2 is x. So we get 1 over x square y prime minus 2 over x cube y equal to 1 over x. So the left hand side can be written as the derivative of 1 over x square times y, the derivative of that equal to 1 over x. So if you notice here, when you differentiate this, it's 1 over x square times derivative of y. If you apply the product rule, that will be y prime. Then y times derivative of 1 over x square, which will be negative 2 over x cube. So the purpose of finding this integrating factor is to make only the left hand side of the equation 2 a perfect differential. Now you integrate both sides. So we get integral of 1 over x squared y prime dx equal to integral of 1 over x dx. So by fundamental theorem of calculus, if you have integral and inside derivative, they are kind of opposites of each other or inverses of each other. So you get the function back 1 over x squared times y equal to integral of 1 over x, which is ln x plus c. Technically it is ln of absolute x, but we are given x is positive, so we can just write ln of x in the place of x. So it is equal to ln of x plus c. So y equal to x squared times ln of x plus c. So that is the solution to this problem. Hope this video helps.